Good morning, everyone. Today we learn about mobile IP, the last topic under the first part of module number 4. As we know, mobile as well as the personal computer, such as notebooks, are becoming popular nowadays. And since this will be used for communicating purpose, so some research has to take place about this mobile IP or extension of IP protocol that allow mobile computers to connect to the internet at any particular location wherever the connection is available or connection is possible. So mobile IP is an Internet Engineering Task Force, or we call it as IETF, Standard Communication Protocol, and that is designed to allow mobile devices users to move from one network to another while maintaining a permanent IP address. That is, while maintaining the permanent IP address, a mobile user can move from one network to one more network and he can communicate. As a mobile and a personal computers such as notebook becomes increasingly popular, so we need to work on mobile IP. So it is a wireless communication or it may be wired communication. So wherever it is possible, we have to try to connect the system to the given network and we have to work from that particular place. The main issue in mobile communication is the IP address or the addressing. The main problem that must be solved in providing mobile communication using IP protocol is addressing. Reason because the host or the device might be stationary or it might be mobile. So there are two issues which comes under this. So we'll discuss about the stationary host as well as mobile host. Stationary host. The original IP addressing was based on the assumption that the host will be stationary, that is, it will be attached to a one specific network. A router will be used as an IP address to route the packet or to route an IP datagram. So using this particular IP address, packet used to be routed. So in the case of IP addressing, we have seen an IP address consists of two parts. One is called as prefix, one is called as suffix, and the prefix is associated with the host with a network. So that will be the network address. So prefix will be the network address and suffix will be the address of the device. And the address is valid only when the host is connected to that particular network. If the network changes, the address is not valid or it is not will be or a valid one. So router use a association to route a packet. They use a prefix to deliver the packet to a network which the host is attached. So based on the prefix, the particular network will be identified, and based on that the packet will be routed. And the second type of host is mobile host. When a host moves from one network to another, the IP addressing structure need to be modified because it is moving. So mobile, which means moving. So there are few solutions to this. One we call it as changing the address. That is when we move from one location to one more location, the changing the address has to take place. Second option is to have two addresses. So instead of having one addresses, two addresses, one within the network and one more when it moves from away from the network. So that is in respect to mobile host. So the first one is changing the address. So one of the solution for mobile IP is to allow mobile host to change its address when it goes to a new network. So the host can use DHCP to obtain a new address to associate with the new network with the new network. But there are several drawbacks in this particular uh, method. The first drawback is the configuration file would need to be changed. So when you move from one address to one more address, so configuration file has to be changed. Second one is each time the computer move from one network to one more network, it has to reboot again. Third drawback is the DNS table need to be revised each time. So whenever you move from one network to another network, the DNS table associated with it has to be revised. And the last one is if the host roams from one network to another during the transmission, data exchange will be interrupted. So whenever the data transfer has to take place, then the host has to be in only one particular network. You should not move from one network to one more network when the communication is taking place. So that will result in interruption. So these are the four drawbacks when it comes to changing the address. The next option is having two addresses. In this method, the host will have original address called home address, that is when it is in one home address, and it will and a temporary address called a case of addresses. So it will have two addresses. The home address is permanent. It associate the host with its home network, that is where it will be all the time. The network, that is permanent home of a host. The case of address is temporary address. When a host moves from one network to another, the care of address changes. It is associated with the foreign network, that is external network, the network to which the host moves as shown in this particular diagram. So you can see this is home network. So this address we call it as home address, and this is internet, and this is what we call as foreign network, that is whenever the device moves from this network to this particular network, that is from home network to foreign network, we call that particular address as care of addresses. So the same device will have multiple, I mean two addresses. When it is in host, that is in home network, we call it as home address, and when it goes to the other network or foreign network, we call it as care of address. Next, there is something called agent, which is associated with the home network as well as the foreign network. So to make the change of address transparent to the rest of the internet requires a home agent as well as a foreign agent. As you can see in this figure, the position of a home agent uh, is with respect to home network. So this is home agent, this is with respect to home network, and there is something called foreign agent, this is with respect to the foreign network. Home agent is usually a router which is attached to the home network of the mobile host. The home agent acts on behalf of mobile host when a remote host sends a packet to the mobile host. The home agent receives the packet and sends it to the foreign agent. So it will act as a router between the home network as well as a mobile host. Similarly, second one is foreign agent. A foreign agent is usually a router which is associated with foreign network as similar to our home agent. The foreign agent receives and delivers the packet sent by a home agent to the mobile host. So it is going to receive and deliver the packet sent by a home agent to a mobile host. A mobile host can also act as a foreign agent. That is, mobile host and the foreign agent can be the same. However, to work as a mobile host as well as the foreign agent, the mobile host must be able to receive a care of addresses by itself, which can be done through a use of DHCP. In other words, we can say that mobile host needs a necessary software to allow it to communicate with home agent and to have two addresses. So by making use of a proper software, it can act as mobile agent as well as a foreign agent, and based on the switching it can have two addresses. When the mobile host acts as a foreign agent, the care of addresses is called collocated care of addresses. That is, when a mobile host acts as a foreign agent, both as uh, the mobile host as a foreign agent, then the care of address associated with it we call it as collocated care of address. Whenever a communication has to take place between a remote host and a mobile host, then it has to go through three different phases. The first phase is called agent discovery. You can see in this particular diagram. First one is agent discovery. Second one, phase 2, which is called as registration. And the third case, the last case, which is called as data transfer. So first one is agent discovery, second one is registration, and the third one is data transfer. So as you can see here, phase 1, there are two types of operation. One is agent solicitation and agent advertisement. Similarly, there is something called agent solicitation and agent advertisement in case of agent discovery. In phase 2, that is in registration, there is something called registration request and registration reply. And last case in data transfer, there is an operation called data transfer. In the first phase, that is in case of agent discovery, uh, it involves actually three agents. That is, one is mobile host, foreign agent, as well as home agent. Similarly, the second phase, that is in registration, also involves three types. One is it is going to involve home agent, mobile host, and foreign agent. That is same as the phase 1. And in case of third phase, here along with mobile host, foreign agent, and home agent, it is going to involve remote host too. So these are the three different phases and the agents and the host involved in the operation. Now let us study about agent discovery, registration, and data transfer. The first one is agent discovery. Uh, as I said, it is a first phase in mobile communication is to identify the agent, and it consists of two sub phases. Mobile host has to identify a home agent before it leaves its home network. So whenever it want to move out of its home network, first it has to identify a home agent. A home agent or the mobile host must also discover a foreign agent after it has moved to a foreign network. So when the mobile host moves to a other place than its home network, then after once it moves to other network, it has to identify its foreign network. This discovery consists of learning the care of address as well as the foreign agent's address. So it has to identify care of address as well as foreign agent's address. This discovery involves two types of messages. One is called as advertisement. Second one is called as solicitation. So the first one is agent advertisement. When a router advertises its presence on a network using ICMP router advertisement, it can append an agent advertisement to a packet if it acts as an agent. So you can see in this figure which shows the agent advertisement is piggyback to the router advertisement packet. So this consists of uh, different fields like type, length, sequence number, lifetime, code, reserved, as well as care of addresses. So when it comes to type, as you can see here, the type, it's a 8-bit field is set to 16. So it is a 8-bit type field which is set to 16. Second one is length. The 8-bit length field defines the total length of the extension message. So it is going to give the length of total length of the extension message. Next one is sequence number. A 16-bit sequence number field holds the message number. So it is going to hold the message number. Next one is lifetime. The lifetime field defines the number of seconds that the agent will accept request. So the duration for which the agent is going to accept the request. So if the value is a string of ones, the lifetime is infinite. So if that particular value is a string which consists of ones, then the lifetime is infinite. Next one is code. A code field is an 8-bit flag in which each bit is set to 1 or unset or reset, that is 0. The meaning of this bit is shown in the table below. So if that bit is 0, the meaning is registration required, no collocated care of address. If that bit is 1, then agent is busy and does not accept a registration at this particular moment. If it is 2, then agent act as home agent. If that bit is equal to 3, then the meaning is agent act as a foreign agent. So 2 is home agent, 3 is foreign agent. If that bit is equal to 4, then it says agent uses minimal encapsulation. If the bit is equal to 5, agent uses generic routing encapsulation, that is GRE. If the field is equal to 6, that is field bit is equal to 6, agent supports header compression. And if it is 7, which mean it is unused, that is unused. The last field is care of addresses. This field consists of list of addresses available for the use as care of addresses. So it will consist of a list of addresses. The mobile host can choose one of these addresses. The selection of this care of addresses is announced in the registration request. So during registration request, which of the address has been selected, that will be announced. Note that this field is used only by the foreign agent. So this care of address used by only the foreign agent. The second phase in that is agent solicitation. When a mobile host moved from one network to a new network and has not received agent advertisement, then it can initiate agent solicitation. So it can use the ICMP solicitation message to inform an agent that it needs some assistance. So it can be initiated by a mobile host which has gone to new network and it has not received any agent advertisement. In that case, it can raise or it can request the solicitation message. So the second phase is registration. So the second phase in mobile communication is registration. After once the mobile host has moved to a foreign network, and discovered a foreign agent, then it must register. So there are four aspects of registrations. So the first aspect is the mobile host must register itself with the foreign agent. Second one, the mobile host must register itself with its home agent. This is normally done by the foreign agent itself on behalf of mobile host. Third one is mobile host must renew registration if it has expired. Fourth one, the mobile host must cancel its registration when it returns to home. So the first aspect is, so the mobile host must register itself with foreign agent because it has moved from home network to the foreign network, so it has to register with the foreign agent. Second one, the mobile host must register itself with the home agent, so it has to link with the home agent. So usually that will be done by the foreign agent itself. Mobile host must renew registration if it is expired, that is if it registration is expired, then it has to re-register. And the last one is mobile host must cancel the registration when it goes back to the home network. So these are the four aspects under registration. So as we saw, so registration is a process wherein to register with a foreign agent and a home agent, the mobile host uses two steps, which is called as registration request and registration reply. So as you can see here, in the previous diagram there was something called registration request and registration reply in order to uh, register to complete the registration. So the first one is registration request. A registration request is sent from a mobile host to the foreign agent to register its care of address and also to announce its home address and home agent address. So it is a request sent from the mobile host when it moves to a mobile network, and this is done in order to get its care of address or to register its care of address, and also it is going to announce its home address and home agent address. The foreign agent, after receiving this registration request, relays the message to the home agent. It's going to reply the message to the home agent. uh, we have to note here that home agent now knows the address of the foreign agent because the IP packet that is used for replying the IP address of the foreign agent as a source address. Now it has got a IP address with a source address mentioned in that. So this is the diagram which shows the registration request format. So in this we have something called type, flag, lifetime, home address, home agent address, care of address, identification, and extension. So these are all the different fields available in registration request format. That is a request from the mobile host to the foreign agent. So we'll see what is this fields now. First one, as I said, it is type. So this is a 8-bit type field, defines the type of message. For a request message, the value of this particular field has to be 1. Second one is flag. uh, Once again, this is an 8-bit flag that is going to define the forwarding information. The value of this each bit can be set and reset. So there are different meaning for this 8-bit flag, and we can set and reset the values. The meaning of this bit has been given in the table below. So if that flag bit is 0, then the mobile host requests that home agent retains its prior care of address. If the flag bit is equal to 1, then it means mobile host requests that home agent tunnel any broadcast message. If the flag bit is equal to 3, then it indicates mobile host is using collocated care of address. If that bit is equal to 3, then it means mobile host requests that home agent use minimal encapsulation. If that bit is equal to 4, it indicates mobile host request generic routing encapsulation. If that bit is 5, it indicates mobile host request head header compression, and if it is 6 or 7, then it is then it is reserved bits. So based on this particular bit in the flag, the different operation can takes place. After this, we have a field called lifetime. This field is going to define the number of seconds the registration is valid, the duration for which the registration is valid. If the field is a string of zeros, if this particular field, that is lifetime, is a string of zeros, the request message is asking for deregistration. So as I said, at the end of it, it has to perform deregistration. That can be done when all the bits of this is equal to 0. If the field is string of 1, if entire bits are ones, then the lifetime is infinite. The next one is home address. This is the field contains the permanent address of the mobile host. That is the initial address, the first address. Next one is home agent address. This will contain the address of the home agent. So the agent address, that is home agent address, what was there, that will be specified here. Next one is care of address. This field is temporary or the second address of the mobile host. So when it comes from home network to the foreign network, so what is the address has been given, that will be in this field, which is called as care of address. Next one is identification, and this field is of 64-bit that is inserted into the request by the mobile host and repeated in the reply message. So this is an identification code which is inserted by a mobile host when it is going to request, and the same thing will be mentioned when it is going to get a reply. So based on the matching, the request and the reply will be allocated to a particular mobile host. Last field is extensions. It's a variable length and it is used for authentication. So they allow a home agent to authenticate with a mobile agent. So using this, as I said, it is a variable length and which will be used for authenticating the home address to the mobile agent. Next one is registration reply. A registration reply is sent from a home agent to a foreign agent and then a reply to the mobile host. So it will be from home agent to the foreign agent and then reply to the mobile host. The reply confirms or denies the registration request. So it can do either, it can confirm or it can deny based on the registration reply format shown in this particular diagram. So the fields are almost similar to those of registration request. Even there we had type, code, lifetime, home address, home agent address, etc. The value of the type field here it is 3. The code field replaces the flag field here. So here we have code field wherein we had there as a flag field and shows the result of the registration request, that is either acceptance or the denial in this particular reply. The care of address field is not needed here, so it is not used here. the whatever the registration messages are there, that will be encapsulated in the UDP user datagram. An agent uses a well-known port 434. A mobile host uses an empirical port. So it will be sent through a port which is known as port 434. And the last uh, phase is the data transfer. So first we have seen agent discovery. Once that is done, the registration phase will takes place through request as well as through reply. Once this is done, the final phase is data transfer. After, as I said, the discovery and registration, the mobile host can communicate with a remote host as shown in this particular diagram. So this is home network, this is the home agent, this is the internet. So this is the foreign agent. You have one mobile host here in a foreign network. Similarly have a remote host and a remote network which are connected through an internet. First we will see from remote host, that is from this to the home agent, that is this. So when the remote host want to send a packet to a mobile host from here to here, it uses its address as a source address and home address of the mobile host as destination address. So it will take this address as the home address, that is a source address, and home address of the mobile host, that is a home address, this address as a destination address. In other words, the remote host sends a packet as though the mobile host is in its home network. The packet, however, intercepted by a home agent which pretend it as a mobile host. This is done using proxy ARP technique, which will be seen in the coming slide. Second one, from home agent, that is from home agent to a foreign agent. So after receiving the packet, the home agent sends a packet to a foreign agent using the tunneling concept. So this is called as tunneling, which will be used whenever a network goes from one form of addressing to one more form of addressing, something like IPv4 to IPv6. The home agent then encapsulate the whole IP packet inside another IP packet using its address as a source and foreign agent address as a destination. So this is the path. So initially the path established from remote host to the home network. Now from this home network to this foreign agent. Now the third one, from foreign agent to a mobile host. When a foreign agent receives a packet, it moves the original packet. However, since the destination address is the same as the home address of the mobile host, the foreign agent consults a registry table to find the care of address of the mobile host. The packet is then will be sent to the care of addresses as you can show in this. That is the path number 3. The last one, from the mobile host to remote host, from the mobile host to the remote host. So when the mobile host want to send a packet to a remote host, then it sends as it does the norm in the normal operation. The mobile host prepares a packet with its home address as a source address and address of the remote host as the destination address and sends the packet. All the packet come from foreign network. It has the home address of the mobile host, which is shown in this the path 4 from mobile host to the remote host. So this is about mobile IP, the different types of addresses like uh, host address or the mobile address, and then we have seen about agents, home agent and foreign agent, and the three different phases in data transfer. Thank you. related to assignment. Uh, One assignment is question number one is explain the three phases of communication between a remote host and a mobile host. And question number two is what is the two addresses approach used in mobile host? Explain the significance of home agent and foreign agent with a neat diagram. So question number one is to explain the three different phases in mobile communication, and question number two is to explain about addresses approaches used in mobile host and explain the significance of home agent and foreign agent with a neat diagram.